Let's look at properties of logarithms. So here we are going to look at one called the product property. Then there's a quotient property. That makes sense, multiply and divide. But there's also a power property. And I'm going to show you how we use these. And then we're going to do them in some equations. Okay. So this one here, let's look at one Roman numeral lowercase 1. And what I see here is two bases that are the same. If the bases are the same, then you can apply the product property, which means that if it's adding, you can combine them as multiplication. So look at what I do. I combine the logs, but I make it, instead of plus, it's multiplying, but there's only one log now, which means now that's log base 2 of the number 28. That's applying the product property by condensing it. I have this bigger long one, and what I just did is I condensed it by multiplying the 4 and the 7, and combining the logs, essentially. That's one way to think of it. So we get log base 2 of the number 28. Now let's do that over here with this one. This one we're going to do backwards. We don't have two of the things. What we want to do is we're going to split that up into log base 3 of something plus log base 3 of something, as if it was that way before we condensed it. So this one's what's called expand. In fact, I think I'm going to write that here. We are expanding this one, and this one we're condensing. So here I need to think, I have log base 3, so I'm going to be doing log base 3 of something plus log base 3 of something. What are those somethings? Well, let's take the number 80, and since we know the 80 was gotten to by multiplying two numbers, just like the 28 over here, let's split the 80 up into two numbers. Well, we can do 8 times 10. Wait a minute, that's true. I can also do 4 times 20, and I can do 2 times 40, and I can do 5 times 17, 18. I believe it's 18 here. Yeah, 50, 60, and 30 is 80. I have bunches of choices. Oh, which one do I use? Any one of them. You could choose any one of these. We could actually break this up in these 4 different ways and more, because let's see, 2, 3, 4, 5, 16. I guess maybe that's it. Well, I'm going to take one of them. I'm going to take, I guess, the 4 and the 20. I could have chosen another one. Who cares? I just could have done it. I just chose this one. Plus log base 3 of 20. So if you put this one in the calculator, and then you did this plus this one in the calculator, you'd find you get the same answer for it. So this is one way it could be broken up. We've expanded it into this. Although I could have used the 8 and the 10, or the 2 and the 40, or the 5 and the 18 if I'd wanted to. Okay. Now, the quotient property is the opposite. Here you have adding leading to multiplying, or multiplying leading to adding. Now we're going to do dividing and subtracting. So when we see that this is subtracting here, that means now we're going to do the log base 2, but we're going to do it now of a fraction with the first number on top and the second number on the bottom. That's all we have to do. We just have to put the numerator and denominator. As long as they're the same base number, the 2, and it's subtracting, then we make a fraction. This can be reduced. So now we see that this can be log 2 of the number 5. And that would be the, 15 I meant. Log base 2 of 15. Wait a minute. No, it is 5. 30 divided by 6 is 5. Okay. So log base 2 of 5 here. Now over here with log base 2 of 5 in Roman numeral 2, lowercase, what we have is finding ways to, like here, this number was the result of 30 divided by 6. Well, we can still do that. 5 can be 30 over 6, and we can go backwards and make it the minus between those two. Or we can do other ones. We can do 50 and 10. We can do 35 and 7. We can do 550 over 11. Now, does that work right? No. Trying to get a 5, which means it would be 110. I could do that, right? Because 11 goes into 55 5 times. That would be weird. Oh, it's doable. Let's do that one. Log base 2 of 550 minus log base 2 of 110. Because this one could be seen as log base 2 of 550 over 110. Or as 30 over 6, 50 over 10, 35 over 7, 40 over 8, 45 over 9, numerous possibilities. But this one will work just as well because it does give us the result of 5 if we were to now go the opposite way and condense it. So this one's been expanded and this one was condensed. Now let's look at the power property, and that one is in some ways easier. If you have an exponent here of the number that you are waiting to get the logarithm for, you simply can put that in front. X log base 9 of 20. If you have a number that's the coefficient, you can bring that and you can put that here in the back as an exponent. Log base 3 of 7 squared, which is log. Oh, let's clean up some of these things. I was writing too fast. Okay. Log base 3 of 7 to the squared, which is actually equal then to log base 3 of 49. So in one case, we took the exponent, moved it back, and the other case, we moved it in front. And you're allowed to do either one of those, depending upon a certain equation, a certain problem, you're going to want to do it one way. But this is one of the easier ones. You don't even have to think much about it. You just move it. And then you might have to multiply something like it was here, but you just move it. Simply just that. Just move the one thing. And that's the power property. Now, let's use these. We're going to solve the properties, and there's going to be two techniques we look at, and that's deleting and reformatting. And we're going to use those three properties to do it. So let's look at this first one and follow through what I do with this. I see this minus and I want to do the division thing, but I cannot do it. This is very important. Okay. Cannot do it while there's a coefficient. Must move it first. I clean it up kind of thing. So if I bring that up to the x, I now have log base 5x to the third power minus log base 5 of 4 equals log base 5 of 16. Now we can take care of doing this one as an exponent or as a division thing here. Now, this is where what happens is that essentially if these bases are the same with an equal sign and nothing else outside of the logs that are complicating it, if these log base 5s are correct, that forces the parts inside to be equal to each other. X to the cubed over 4, x to the third cubed, is equal to 16. This thing and this thing now are equal. Just like exponents would be equal if you had two bases that were multiplying to each other. But here in this case now, we will solve for x by doing this. We'll multiply by 4 on both sides, so that x cubed becomes 64. And then we're going to take the cube root of x to the third and the cube root of 64, which means that x is equal to 4, because 4 times 4 times 4 is 64. And we've just solved it. If you were to put that back in here to this x, and then did that in the calculator, do that in the subtracting, multiplying, and all that, you would get the number on the other side as well. This is called deleting because it's almost like we are deleting these logs here. We're not really deleting them, but it looks like it. What it is just that if those logs are the same, then the inside parts have to be the same as well. So we're just taking them out and using them. But it's nice to call it deleting. So we're going to do the same thing now with this one, but this time we have an exponent there. Okay, in fact, I'm going to pause for a second and say, why don't you do that one yourself? Okay, do that one. You can see the method on the top one. You see it's not a hard one, but do the steps for it and pause the video and come back as soon as you're done. Okay, welcome back. So the first thing I need to do is bring that up there. And so I have log base 7 of 4x minus log base, to write that better, is log base 7 of 3 squared, which is 9. Log base 7 of 5. Now, these ones can now be condensed to log base 7 of 4x over 9. Notice the one that's being subtracted is always on the bottom, is equal to log base 7 of 5. Because these are the same, that means we essentially cancel them out, or not necessarily cancel them out, but we are making the insides equal to each other. So now at this point, I'll just solve it as normal. Multiply both sides by 9, 4x equals 45, divide by the 4 on both sides, and I get 11.25 or 11 1/4. And that's what my x is equal to. Okay. If I put that x back in here and did all the calculations, I would see that the two sides are equal. So in this case, this is a deleting. You're deleting something. The other thing we're going to do is reformatting. Okay, so in reformatting, we're going to do something you have seen already, but first let's do the properties here. This is adding, but I don't see any exponents, so I don't have to apply the power property yet. So I am going to do now log base 4, and I'm going to multiply these things. So it's x times x minus 6 is equal to 2. I'm going to multiply it yet, but notice something. I have log on only one side. Back on these two problems above here, we had log on both sides. So we ended up with this situation where we had log on both sides and it allowed us to simply use the insides being equal to each other. In this case now, we don't have log on the other side, so we can't do a deleting thing. But what we can do is take the base number and bring it over here, reformat this as an exponential function. So I get x minus 6, and the 4 forces the 2 to go up there as a exponent. So let's actually continue to work this out. Now, what do I do with this? Well, I'm going to move the 16 over to the other side because it gives me a quadratic, and that means I'm able to solve for it. That's minus 16, because it would be subtracting 16 on both sides is equal to 0. Now, and now that I get to this point, I also see too that I have a square. That means I have 2 answers to this. Okay, I may have 2 answers. I should have 2 answers. Let's figure it out. So when I'm looking at this, I can put that in the quadratic formula because it's a quadratic with a base 2, or I can attempt to factor it. So I think the factoring could work here because x times x multiplies the x squared. And for negative 16, I have lots of choices: 16, 1, 4, 4, and 8, and 2. But a negative 8 and a positive 2 would add up to the negative 6. And they each get their own separate equals. X minus 8 equals 0, so x is equal to 8. X plus 2 is equal to 0. So x is equal to negative 2. Now, this is very important. That is check. Because what you check for is whether or not you have a negative inside the exponents. And right now, that would happen here if I use negative 2. Oh no! If I put negative 2 in here, I'd have a logarithm of a negative. Cannot do that. If I put negative 2, we get a negative 8, and we still can't do it. So that means this is extraneous. And if I just do a look at using 8 in there, 8 in here would be fine. And 8 take away 6 would give me a positive number. So that makes the x equals 8 an acceptable answer. So even though it's x squared, we only have one answer for this one that will make it correct, because of the rules of logarithms that you cannot have a negative for the number you're trying, for the log number, for the number that you get as a result of using the base and the exponent. This next problem is the same exact type of thing, right? So let's first go over this here. So what I first did is I used the plus to make this multiply and put them together. Then, so one was the product property. And then two is I made it exponential. I reformatted to an exponential function. And then all I did was solve for x after that. Solve for x. So it's those three steps. 1, 2, 2, and 3. Let's apply these steps down here to this next problem. Go ahead and do that yourself. Pause the video, do it, and then come on back, and let's see if you can get it. Oh, we have a change first. We have a change. In order to get this one right, this needs to be a, here, hold on, this plus needs to be minus. Okay, plus I wanted it to be different from the one above it. So let's make that a minus, please. So please do that problem with log base 2 x minus 3. Subtract log base 2 of x plus 3 equals 2. All right, go ahead and do that now. Welcome back. With this being a negative, okay, we are going to do log base 2 x minus 3 over x plus 3 equals a 2. And actually, that's this whole thing. Now I'm going to change it to the logarithmic function and bring that 2 over there. So I get no more log, and I get x minus 3 over x plus 3. I'm adding parentheses here to keep them together. And this is 2 squared. 2 squared is actually written better as 4. And now my next step would be to either think of it as cross multiplying, or think of it as using this denominator, and I'm going to multiply both sides by that denominator. So let's come back up here to continue it from the bottom of the page. These will cancel out, and I get x minus 3 on that side. And on the other side, I'm multiplying the 4 to those, so it's 4x plus 12. We did the distributive property there. Well, I have all these x's here, and I can either move them one way or the other. I think it's safest, and the numbers as well. I think it's safest if I move the x's over here, all that side, because it'll be a positive x. And so I get minus 3 is equal to 3x plus 12. I have to get the numbers together, so I might as well do subtracting for that one. Right? And that one gives me negative 15 equals 3x. Oh, but this now becomes a pretty easy answer. Let's divide by 3. So x is equal to negative 5. Now let's remember to go back and check up here to see if we get any negatives in there. And oh, look at this. That's going to make a negative 2. We can stop right there and say that answer is no good. Over here, yeah, I'll make a negative 8. So that means cannot be done. Okay. So I'm going to say not equal to. Well, it's not necessarily that's not equal to. It's just that when there is no second answer, like there was in the problem above, that means there's no answer possible here. And if there's no answer possible, that is a no solution situation. And that's the phrase I want you to use, is no solution. Well, now you've seen what those 3 properties are and how you can use them with deleting if you have logs on both sides of the equation of the equal sign, or reformatting if you have a log only on one side of the equation. So follow these examples because you're going to see these again. I hope this was a helpful explanation and examples, and thank you for watching and listening.